I won't pretend to totally understand, but the way you describe it then, you make it sound like something corrupted, something went wrong, everything was fine, and then as the universe cooled, something broke.
Yeah. Breaking of symmetries is absolutely vital for our existence. It's sort of counterintuitive. Almost at every level in our universe, that when we think of it in terms of particles, you need to break some beautiful symmetry that's been there at some earlier stage in order for something interesting to happen. Another example is in the very early universe, we think that the universe was beautifully homogeneous and isotropic. There was no unique place to be. All particles will have been evenly distributed. And if that's the case, then gravity could never act to cause things to collapse together. Because if everything was beautifully symmetric, so every particle was the same distance away from every other particle, gravity wouldn't know which one to actually pull on more than any other. So what's needed is some way of just breaking that beautiful distribution of particles. Some perturbation is required to break that symmetry. Then gravity can start pulling things around the particle that's been pushed further than every other particle. And that leads to structures. And the same thing's going on here with the Higgs. It's that the universe is beautifully symmetric early on, but as it cools down, you have to break that symmetry in order to generate some masses on the particle. If you don't break the symmetry, you won't generate any masses and everything would remain massless. And that's not the universe we live in, Brady.